My dear students, Assalamu alaikum. In this lecture, we are going to discuss one more type of frequency diagrams, which is frequency polygon. Students, a frequency polygon is a graphical form of representation of data which is used to depict the shape of the data and to depict the data trends. It is a graph which is constructed by using lines to join the midpoints of each class interval or each bin. Or we can say it is constructed by joining midpoints of the tops of all rectangles in a histogram. The height of the pointers represent the frequencies. Dear students, a frequency polygon can be drawn both with the help of a histogram and also without the help of histogram. Thus, there are two ways in which a frequency polygon may be constructed. First, with the help of histogram, and second, without the help of histogram. How do we do it? Let me explain you. Let us first understand the construction of frequency polygon with the help of a histogram. Students, the first step to follow is to draw a histogram from the given data set. And how to draw a histogram, we explained that in our previous lecture. So firstly, we have to create a histogram. After creating the histogram, find the midpoints for each rectangular bar that exists on the histogram. Then the third step is to join the midpoints of the upper horizontal sides of each rectangle with the adjacent ones by a straight line. Then close the polygon at both sides of the distribution by extending them to the baseline. The figure so formed is called a frequency polygon. Let us consider an example to understand this process in a better way. In a batch of 400 students, the height of students is given in the table as given in the slide, and we have to represent this data with the help of a frequency polygon. The first column of this table gives the height of students in centimeters, and the second column gives the number of students in each class range. These data have been presented with the help of a frequency polygon as shown in the figure given here. In the figure, the height of students are represented on the x-axis on a suitable scale as shown. The number of students, or we can say frequencies, is represented on the y-axis on a suitable scale. As we can see here, that there is no data value greater than 0 and less than 135. The jagged line that is inserted on the x-axis is used to represent this fact. Now, rectangular bars of width equal to the class size and the length of the bars corresponding to a frequency of the class interval is drawn. After creating the histogram by following these steps, midpoints of the tops of rectangles in the histogram have been marked as shown by point B, C, D, E in this figure. Then join these midpoints using a scale. The resulting curve is the frequency polygon. The important point to note is that the endpoints of the polygon be joined to the immediate lower or higher midpoints, as the case may be, at zero frequency with the baseline. That is, we have to close the polygon at both sides of the distribution by extending them to the baseline as shown by point A and point F in the figure. It is done to equate the area of frequency polygon with the area of histogram. Thus, dear students, the area under the frequency polygon is always the same as the area under the histogram. Dear students, this method is used to draw a frequency polygon with the help of a histogram. We can also construct a frequency polygon without drawing a histogram. Let us see how. The steps to follow while constructing a frequency polygon without drawing a histogram are given in this slide. The first step is to calculate the class mark, or we can say midpoint or mid value for each class interval. The formula for calculating the midpoints of class intervals is mid value of class interval is equal to lower limit of the class interval plus upper limit of the class interval divided by 2. Then mark the mid value of each class interval on the horizontal axis, or we can say on the x-axis. After that, mark the frequency of the class on the vertical axis or y-axis corresponding to the frequency of each class interval. Mark a point at the height in the middle of the class interval. That is, we have to plot the given frequencies corresponding to each class mark, that is each mid value of class intervals. Make sure that the frequency is plotted against the mid values of class intervals and not against the upper or lower limit of any class. Then join all the plotted points using a line segment. The resulting curve is the frequency polygon. Let us consider an illustration to understand it in a better way. The distribution table given in this slide represents the test scores of students, and we need to represent the data given in the table with the help of frequency polygon without drawing a histogram. Students, the first step is to calculate the midpoints or mid values of each class interval with the help of the formula, which is mid value of class interval is equal to lower limit of the class interval plus upper limit of the class interval divided by 2, as shown in the second column of this table. In the second column of the table, we calculated mid values of the class intervals. Let us take the first row, that is the class interval of 49.5 to 59.5. The mid value is equal to lower limit of the class interval, which is 49.5 plus upper limit of class interval, which is 59.5 divided by 2. So 49.5 plus 59.5 divided by 2 is equal to 54.5. which is the mid value of first class interval. Similarly, we do it for the rest of class intervals. So we have got the mid values of the class intervals as 54.5, 64.5, 74.5, 84.5 and 94.5. Now first draw a set of axes with frequency on the y-axis and test scores on the x-axis. On the x-axis, we mark the mid values of class intervals such as 54.5, 64.5 and so on till 94.5 by using a suitable scale. Note that we will also mark the previous and next mid values to start and end the polygon at zero frequency. That is, we plot 44.5 and 104.5 on the x-axis as well. Then the frequencies corresponding to mid values are plotted against each class mark or against each mid value. After that, join the plotted pointers with straight lines in order to get the frequency polygon as shown in the figure. A frequency polygon usually extends 1 unit below the smallest bin value and 1 unit beyond the greatest bin value. Like in this figure here, the frequency polygon extends to 44.5 and 104.5 at zero frequency while touching the x-axis. These plotted pointers are used only to give a closed shape to the polygon. Dear students, if the pointers of a frequency polygon are joined not by straight lines but through a freehand smooth curve, it will be known as frequency curve. Thus, a frequency curve is a curve which is obtained by joining the pointers of frequency polygon by a freehand smooth curve. The curve is drawn freehand in such a manner that the area included under the curve is approximately the same as that of the frequency polygon. Dear students, frequency curve is just a variant of frequency polygon. It is a limiting form of a histogram or frequency polygon. If we draw the frequency curve with the help of histogram, it will look like the curve as shown in this figure. And if we draw the frequency curve without drawing a histogram, the curve will look like this as shown in this figure. The construction of a frequency curve is similar to that of a frequency polygon. The only difference is frequency curve is drawn using freehand and frequency polygon is drawn using straight lines. Thus, when frequency polygon is smoothed, then it is known as frequency curve. Thank you.